Friends, today we will discuss about the integral factor. Generally, it happens that uh, we use an integral factor, which is integral factor is equal to e to the power p dx, integration of p dx. But today I want to say that why, from where this is coming, and what is the concept behind this. Actually, if you try to integrate this one directly, you will say that dy is equal to q minus py dx and integrate both sides. But you cannot integrate like this, because if you are integrating with respect to x, at that time you cannot consider y as a constant. So y is also variable and x is also variable. So there is a need of some function that you multiply in both sides, and that function uh, will make this equation as an exact differential equation, and from there we can be able to solve this differential equation. Let me explain how. Let's multiply by a function which is equal to r. You can say r is equal to x comma y. R is you can say r is the function of x comma y. I am multiplying by r dy by dx plus p ry is equal to q r. R is the function of x y. So now you can say r dy by dx plus p ry is equal to q r. Now you know that if I say that if you take y r and integrate this one with respect to x, what you will get? You will get focus here, r dy by dx plus y dr by dx. So that will be r y dash plus y r dash. So if you just compare this and this, what will happen? So r y dash, you can compare this one and this one. What you will get? R y dash plus p r y and y r dash. So I can say that p uh, r is equal to r dash. You are getting my point? I want to make this exact differential equation, and for that it is important that I can consider like this. So if I want to make this one exact, so I will have to approach like this. So r y dash plus and pr is equal to r dash. So this is, now what I will do, p r is equal to dr by dx, dr by dx. Now I can say that p dx is equal to dr by I am using variable separation here, and integrate the both side. So this will become ln r is equal to p dx. This is the p dx. So now you can say that r is equal to e to the power p dx. So r is equal to e to the power p dx. We are getting the value of r, and this r is called the integrating factor. If you multiply this integrating factor in this original differential equation, that will become exact, and that will become very easy for us to solve that whole differential equation. So this is the concept behind this. Actually, we are making this exact, and that will help us to solve. Because it is very easy to solve this one. You can directly say that dx, but little bit it is difficult. So if you say that this whole this side will be equal to dyr upon dx. So you can say dyr upon dx. This whole will be equal to dyr upon dx, and this will be qr. So y, it become y r qr dx. If you integrate this, constant will come. So y r is equal to qr dx plus c. Y integrating factor is equal to q integrating factor dx plus c. So this is the final approach that we use in the linear differential equation. So we have to understand this basic concept. So that will really help us. But generally it happens that we will have to remember all these things. During examination time, you cannot start proving all these things and then solve. We have to remember this step that this is the integrating factor, and then second one is this. So we have to remember this, and this will help us to solve the linear differential equation directly. So these were something concept behind from my side. So I am hopeful that definitely this derivation will help you that from where this integral factor is coming and what is the logic behind it. So I'm hopeful that you get the point. So thank you, friends.